It is, of course, a very a special session. This is a session in which we are celebrating the scientific work of Professor Hema Ramachandran, who has been a dear colleague for many of us for several years, and she passed away in 2020, as many of you perhaps already know. And so today's session is, it is, I would say, it is more a celebration of her science. So that is what Andal is going to do. We have Professor Andal Narayanan with us, who I think, the entire committee kind of was unanimous in agreeing that would be the best person to actually do justice to this session. So she has a very short bio that she has provided us. So Andal did her PhD at the Raman Research Institute, which is here, on light propagation in liquid crystals with defect lattices. She's of course currently a faculty member at the same group as where I am, and many, we have other colleagues at the LAMP group, Light and Matter Physics group. Her research interests are coherent interactions of atoms with light relating to quantum memory, atom-based transducers for microwave to optical conversion of signals, and quantum frequency bin processing through atoms. So in this talk, she is going to present the scientific works of Professor Hema Ramachandran related to optics. This will cover imaging through turbid media, Levy statistics of light scattering in dense scattering media, and random walk of light in frequency space. So with that, I present to you Andal. Andal, are you going to be visible? I mean, yes, you are visible. Okay. So please. Thank you. Yeah.
Good evening to all of you, and I really miss being there for this conference, and especially having been so far away, it feels all the more bad that I'm here. So without much further ado, let me just start my presentation. I'm here to talk about the scientific work of Dr. Hema Ramachandran, who, for younger people in the audience, she was a faculty at Raman Research Institute and one of the founding members of the Light and Matter Physics group. Today we will focus on her scientific work at RRI relating to the topic of this conference. She has done many things besides what I'll be highlighting here. So, Professor Hema Ramachandran, Hema, to all who knew her, left us all in November 2020 after a long fight with cancer. The Light and Matter Physics group of RRI lost a very fine scientist and one of its founding members. She was a feminist, and through her scientific work and everyday life, she walked a path which was rarely taken by a woman of her times. As I said in this presentation, I'll briefly highlight some of her scientific achievements, particularly those which pertains to the topic of this conference. So, a very brief bio of Hema. She did an MSc Physics from IIT Bombay, and she joined the BARC training school for doctoral research and worked in the area of high pressure physics. This, of course, was told to me by Hema. So, during her thesis, she uncovered a novel phenomena where when a material is subjected to high pressure, it actually becomes amorphous. So, this work was widely recognized, and she was awarded the INSA Young Scientist Award. And she could have pursued a very successful career at BRC, but she got married and moved to Bangalore, and she was initially stationed at the BRC Center, Seismological Center, which is at Gauribitnoor. And the office of people who were at Gauribitnoor for the BRC project was at RRI, and that's how our association with RRI started. And during that time, we were PhD students at RRI. This was like 1994, 1995. And that's how we came to know about Hema. We started interacting with her. And in 1995, she was offered a faculty position at RRI to start the optics group, which is now called the Light and Matter Physics group, by the then director, Professor N. Kumar. So, right after I finished my PhD thesis, Professor Kumar, I did my PhD in theoretical I would say, numerically computing the light propagation in electrocrystal media. So thereafter, when as Hema started this optics group, I was asked by Professor Kumar and Hema whether we would like to start with an experiment because we are here to do science and that's what we should do, even though I know there were a lot of associated work just starting the group itself. So I was just looking for a postdoc then, and I had some time in my hands, and I just submitted my thesis. So we enthusiastically embarked upon this experiment, which is imaging opaque object which is immersed in a turbid media. This topic would go on to become her one of her strongest interests subsequently, and she did very many important work thereafter. So basically, the idea is this: you take a turbid media. Turbid media in physics terms would be that such a media, it's opaque media. By what do we mean by opaque media? Is that, let's say, a bunch of initial k vectors of light impinge the media. They suffer multitude of scatterings, and when they exit the medium of a given length, yeah, so they wouldn't have any information about the initial direction with which they impinge the media, nor the polarization, nor any other characteristic you would associate with the entering wavefront or in the k vector picture entering k vectors. Yeah. So thus they would not carry any information about, for example, if there has been opaque object inside the medium, they wouldn't be able to carry the shadow of the object. Unlike if the turbid medium were not there, you would see that the k vectors would indeed be capable of carrying the image, carrying information about the opaque object in the form of a shadow. Yeah. So the question which was out there and which had many practical applications, as you can imagine, was whether in the presence of turbid media, which is considered to be in the diffusive limit of light propagation inside such a media, whether you can image such an opaque object. It had very many applications, especially biological applications where you want to detect tumors in a tissue which is densely scattering. Yeah. So there were, of course, many methods which were there during that time, and all of them relied on the fact that there are photons even in the turbid limit of the scattering particles which are present in the media. There are photons which would travel unscattered, yeah, inside such a medium. These unscattered photons are called the ballistic photons. And they will, of course, carry information about the shadow of the object. And there are also photons which will suffer fewer scatterings around the ballistic path, around the k vector direction of the photon incident in the media. And they would also be partially carrying information about the opaque object. So if one were to filter out these photons amongst the multitude of diffuse scattered photons in the background, one would get the information about the opaque object. This is basically the idea. So the technique which existed during that time is time gating. As you can imagine, photons which suffer fewer or no scatterings would come faster, and thereby a suitable time gating response which captured only response of the detector, which captured only these fast arriving photons, would give you the signal. Of course, with you lose a lot of photons, but then if you have a high enough intensity of incident light, this could be achieved with a sufficient signal to noise. So an idea which existed and which I guess we were one of the few people who did it initially was to do it in the Fourier domain. Let's say you impinge a characteristic a characteristic signature on these ballistic photons. Yeah, what is this characteristic signature? It could be, for example, a rotating polarization. Yeah, which you can achieve by putting a polarizer and rotating it even before the light entered the media. And then let's say the polarizer rotates at a frequency f, then you do not, you can collect data and not with any special time gating, but you can collect data as it comes and then go to the Fourier domain and look at the appropriate frequency bin. And there you'll have information about the information about the opaque object. So this was basically the idea. And at that time, we had very little equipment because the lab was coming up, and we just used legs of an IC pin inside suitable turbid medium. And as you can see, a raw image of it revealed a very faint shadow, if anything. And then post processing in the frequency domain with appropriate spatial filtering yielded the legs of the IC pin. So this was something which was just done, and which caught her interest. I went on to do other things later, and she actually pursued this because it has very many applications. Hema as a person is very interested in finding out whether a particular scientific idea can be taken to a practical application, especially one which benefits people. So she actually pursued this, and one of her latest work in this, which was really very nice work, which I came to know about later, is appeared in this journal, where they actually had a collaboration with people at France, and what they managed to do is image a polarized incoherent source in a tower, which was around 1.2 kilometers away from the detector, and under realistic experimental conditions like fog and stuff like that. This was in Paris, and they were able to image the source. So the source was shown here on the left-hand side, is shown here in the green-colored square, I believe. And then this is kept in a telecommunications tower here. And what is shown in H, I, J, K are the various atmospheric conditions which prevailed during which data was taken. And what is shown on the rightmost side of the figure is the deconvolved imaging using the polarization and frequency gating technique and other further techniques which they developed later. And you can see that the source has been deconvolved with a very high signal to noise ratio. So this is the source here on the J and Kth panel. And every row denotes a certain improvement of the technique which I told you about before. Yeah. So I would say that this work, which was started way back in 1995 and was pursued throughout, and came out with this very good idea of imaging a very tiny source, which was far away, right? Which was around 1.2 kilometers away, which is pretty remarkable. So all of the authors associated with work appreciated Hema's initial contribution in starting the subject. Hema herself was an author in this publication, of course. So one of the things which was easy to do when a lab was starting was, and which was also interesting because we had Professor Kumar here, who was the director, who had very strong interest in light scattering in dense coherent media. So here what is shown, Hema in collaboration with Professor Kumar and one of several of her students, initially Divya Sharma, who's currently in Netherlands, and some of the other master's students pursued this very interesting physics question. I was not involved in it, but we were peripherally witness to all the intense discussions which used to take place. It was an atmosphere of discussion and learning, and all of us learned together, even though we were not exactly part of the work. So this is about light scattering again, but inside a scattering medium where there are these fibers. These are random amplifying fibers of various lengths. Yeah, the fiber length was distributed exponentially, which means, as you can see in the graph here, which is shown in the top left corner, bottom left corner, is a graph of is the distribution of lengths of these amplifying fibers, and you can see larger lengths are exponentially weighted down than smaller lengths. Yeah. So these were deliberately made, and then they were embedded in this medium, yeah, which is a passive scattering medium. Only these fibers were active in the sense that when light goes into the fiber, as is shown here, the intensity of the fiber, the intensity of light traveling in the fiber would grow because there is an active medium inside the fiber. Yeah. So then, what is the question of interest? The question of interest is what is the intensity statistics of noise which is coming out of such a system where active fibers of various lengths, which are exponentially weighted down for increasing lengths, show. Yeah. Why is this an interesting question? Yeah, it's an interesting question because it shows such scattering of intensity or the intensity fluctuations which is coming out of such a medium does not show the Gaussian distribution as one would expect, even for a gain medium. I mean, one would expect gain narrowing, but not necessarily a deviation from Gaussian statistics. But interestingly, these things show what is called a Levy statistics. Yeah. So the Levy statistics is a statistics when there are these rare events which are possible, and these rare events contribute to the statistics with a large measure. Yeah, the largeness of the measure offsets the rareness of the configuration, if you like. Yeah, so people have studied this in a classical analog. I mean, people have studied this traditionally in what is called a Arrhenius cascade. So there is this washboard potential in which there are these random washboard potentials, inclined potential, and let's say a particle is rolling down. Whenever it gets stuck in a potential, the potential well depth is exponentially weighted down for larger potential well depths. So the dwell time showed the dwell time of particles in such a potential well increased exponentially too. So these are these. So there is this concept of larger than rare. Yeah, there are these rare configurations where one would never visit. But if you visit if you happen to be in the configuration, the contribution that rare event gives rise to the overall statistics overwhelmingly large. So what happens is that then such a distribution develops a large tail on the right hand side. Yeah, it's a heavy tail distribution of a regular Gaussian distribution. So this is called the Levy distribution, and Levy statistics is also a universal statistics where the underlying theme is that you have rare configurations, but the contribution of the rare configuration towards the statistics is large. It's larger than rare, is what Professor Kumar used to fondly call it. So as you can see here on the panels, when you take such a medium which is made as I described before and shine light on it with the appropriate frequency so that the active material in the fiber gets pumped, then you can see that what was initially be a Gaussian distribution grow progressively a fat tail and turn into a Levy distribution. One can fit an exponent to the tail of the Levy distribution, and this exponent is universal for that particular scattering media and that particular distribution of the active material, that is the configuration material. Yeah. So this also generated a lot of interest during that time, and because Levy statistics is apparently how as very characteristic of Hema, this is something which also people use heavily in biological systems. Looks like especially how neuron fires in the brain, and so she was very much interested in taking this to practical use, wherein you can use these statistics and study potential firing of neurons in a neurological context in the brain. Yeah, so and then by then I think it was around when they did Levy statistics already. We had a lab wherein around the year 2000 or just before that in 1998, um, Professor Kumar wanted to start a cold atoms laboratory at RRI, and he asked Hema to start this activity explicitly at RRI. Just to bring you the context of cold atoms, around 1995 is the year when cold atoms received the Nobel Prize. 1995, I guess. 1995. No, 1995, the Bose-Einstein condensate was achieved. 1998 or 9, I think the Nobel Prize for laser cooling was given, and thereafter the Nobel Prize for BEC was given. Yeah, so during that time, a lot of excitement around this topic, and Professor Kumar wanted to start this activity at RRI, and he tasked Hema with the task of starting this activity. And so shown here in the photograph are people who are involved in the activity right in the beginning. So there is Meena here on the extreme left, and then there is me here, and this Professor Kumar and Professor R. Srinivasan, and this is Chandrasekhar, who is a faculty at IMSC here, and this is Hema herself. So this is our first mod setup, and it's not an exaggeration to say that we learned optics the hard way when we built the lab. By then I had just come back after a postdoc in Stockholm in laser cooling, and so we all just threw ourselves into the project, and it was, we actually built external cavity drive laser. The large force of let's do it kind of an attitude of Hema, it went a really long way for us to, I mean, this activity was started in 1998, and in 2001, we got our first mod. And this is no mean task because we were all novices, and we even started to, the lasers which gave us the mod, especially the repumper laser, was home built. And people who have done this would know that it's indeed very difficult to have an external cavity dyed laser built with little prior, no experience before. Yeah, and then of course we had giants of people who are motivating us, like Professor Kumar and Professor Aris, um, and it's just a period of, when I look back, it's a period of really unbounded optimism and intense learning. And every day we would come, and there would be discussions of how the atoms travel inside a vacuum chamber, to whether a beam splitter would actually can split a photon intensity 50-50, because Professor Kumar was very insistent photon was boson, so if the beam splitter would choose a particular path, then other photons would also go on that path, and things like that. So it was, looking back, I think no other period in my life, at least, I learned so much in so short period of time, simply because the focus was just doing the physics and getting the pleasure out of it. Yeah. So I think it's an era which would never come back, and yeah, the younger people in the audience should take home the message that the pleasure of doing science is the science itself. Yeah. So once you get that internalized, everything else ceases to matter. Yeah. So yeah. So Hema thereafter, yeah, because we were just building the mod, and we were a little bit far away from doing an experiment which was publishable. So this was a work which I was associated with also. So this is a proposal for a universal logic gate using atom-atom collisions and colliding atoms and their interaction with light. Yeah. So this is, to cut a long story short, let's say inside laser cooled atoms, they collide, and then there are these light fields there. The light fields individually, the atoms cannot individually absorb this light field and go to resonance. But when they collide, because of, or when they are very near the colliding radius, due to the mutual interaction between atom and atom, the levels get shifted, And even though individually they wouldn't be able to absorb the light, together they can absorb, let's say, 2 photons and go to, for example, their respective resonance states. Let's say if you take a rubidium and a cesium atom, and you have lights which are far away resonant from either of the transitions of rubidium and cesium, but when they come together and collide, or by any other interaction, which is atom-atom interaction, the levels get shifted, and the individual energy levels become resonant to the light which is there, and they absorb and go to the excited state. So this was Hema's original idea to develop a control NOT gate. As many of you know, control NOT is a universal gate. So she said she thought about this idea, and we worked on the possibility of control NOT gate in such a system, and we had great fun doing this work. So yeah, I think one of the other work which obviously all these experiments which I'm highlighting here is either I'm directly involved, I was directly involved in, or which I was very interested in knowing. Yeah. So this is one such. This is the quantum walk in frequency space. Yeah, this work was a work which was carried out very successfully by Hema and her students here at the Light and Matter Physics group, and this is simply to ask the question: if there is a quantum walk which has to be realized, and if light were to be the candidate, can we realize a quantum walk in frequency domain? And as many of you would know, would have heard in talks relating to quantum physics, which was there in this conference, is that light has this dubious character, or a very nice character, whichever way you look at it, is that very easily in the wave regime of the light, you can realize quantum properties. And to realize, and in some of these properties can be carried out at very low photon levels, in which the light registering in the detector is particle-like. So what I'm trying to say is that light is such a field. It's also a quantum field. So light is such a thing that you can realize the equivalent of quantum mechanical, what could be a purely quantum mechanical phenomena in a high intensity light regime also. After all, light is a wave, and things like that. So one has to be careful, of course, in reinterpreting the results, and this is one of the results where it carries through even if the light were not in a coherent state and it's in a so-called number state. So what they did is basically show the random walk of light in frequency domain, and unlike random walk, for example, if you toss a coin, then you can ask the question: how many times did one get head, and how many times one gets tail? Then, if you plot the distribution of the number of heads and tails, then you will get a certain distribution. And like as is told very often, that there is a person who is inebriated and who walks in a very random fashion. And then if you plot the distribution of the steps he took, he could go either only right or left. And if you plot the distribution of steps which he took, then the distribution would look like a distribution which is given here on the left-hand bottommost graph, which is the classical random walk graph. Yeah. So in a biased random walk, what would happen is that one would go preferentially towards one direction, so which is shown in the bottom right. Whereas for a symmetric or asymmetric quantum walk in the top right, you would see, because inherently quantum mechanics allows the possibility of the left and right existing at the same time, yeah, the so-called superposition principle. And so you would see that if you cast the quantum walk problem if you cast a random walk problem in the quantum language, you can see, because the fact the superpositions exist, you will see the distribution becoming very different compared to the distribution which you saw, which is the top top right graph on the left. Yeah. So this they managed to show in the frequency domain using what is called acousto-optic interaction. It had very many subtleties in this experiment, which I don't want to go into here, but which could have, if somebody had pursued it, given rise to a lot of fundamental insights into the kind of quantum walk which in the frequency domain. Yeah. So this was done in 2011, and thereafter, before also. So this particular work which I'm highlighting here is also something which she pursued for a few years, and which gave other results too. Yeah. So these are the very few of the scientific work which I've highlighted here, which relates directly to the topic of this conference, which is optics. Of course, she did very many other things, and as people here and some of you who are not at RRI would also know that she initiated the area of brain-computer interface research at RRI, and this was in line with her lifelong interest of taking the research, fundamental research, which she did to the public, especially in the area of biology and medicine. And she collaborated with scientists at TFR on dynamics of photothermally created gaseous microbubbles, which in itself is a very interesting topic. Prior coming to RRI, as I hinted before, she was conducting seismological data analysis for BRC. As you can see, that her interests have been wide, and she has managed to do significant contribution with such a broad interest range. So she was also in the planning team, which recommended and produced large funding for quantum technological initiatives in India, which Urvashi can tell you about if you're interested. So Hema was involved with many academic activities at RRI, and as you would have guessed, she started the optics lab and thereafter started the ultra-cold atoms lab at RRI, for which RRI is now world famous. So she built more than once the research labs from scratch, and it's a no mean activity. And she was head of research facilities for almost half a decade and oversaw many research associated workshops and other things at RRI. And she mentored a large number of postgraduate and doctoral students who have the hallmark of her guiding style was such that they all went on to become very confident individuals. And I think, having been a supervisor and a mother, and I know that how hard it is to maintain the confidence in a young person, and to her credit, to her really, I would say that it's a very strong point in her favor that all her students remember her with such fondness, and they all went on to become very confident individuals and made successful careers in their own right. Yeah. So as a person, I had the fortune of knowing her very closely, and she had a very fine sense of aesthetics. And I think I was introduced to a large plethora of Ravi Verma's paintings through Hema. Just appreciation of these paintings, which I didn't have before. I had it just by interfacing with her. And she, those who know her, know that she carried herself with such grace and dignity. She was a very strong feminist. You wouldn't know, and because she was not very obvious about it. But she would do practically everything by herself. Just to give you an example, there was used to be this heavy chairs in the astrophysics building, which people couldn't move. So all of us would rather moving the chairs and sitting on it would just stand around the chair and talk, because it was, we wouldn't even attempt it. So when Hema comes, the first thing she will do is that she'll say, no, this is not done. So she will try to move the chair herself. Then we would get into action and help her. So this kind of let's do it by ourselves has been the really what I would say to made possible many things which otherwise would have been not been possible at RRI. Let's do it without thinking, oh, whether we can do it or maybe I'm not fit to do it. Because once you start the journey, there are of course many obstacles. But if you have this, let's do it. Let's face it, and let's try and get forward coherently. Of course, is one of the traits which I've tried to imbibe from her. Not very successfully, I guess, but yeah. So even in her later years, when she was besieged by illness, she maintained her very endearing sense of humor, because life is absurd at the end of it in some sense, and so she never let that go of her side. Yeah, so it's good to touch base at how absurd life can be at times, right? Yeah. And as I said before, the genuine affection her students have for her is a testimony to the camaraderie she had with them. And they all went on to become such confident individuals, which is no mean task. And I'm thankful to the organizers for having given to me the opportunity to present some of Hema's work here. It's very fitting, and it's quite sad that she is not around. Yeah. And thank you for your attention.
So I know it's a little difficult to ask questions at this stage. I mean,
yeah, I can answer only questions there. I was directly involved in because it's only there. Yeah.
of course, yeah. But then
people are free to reminisce about Hema, I guess, because the whole idea is to there are people in the audience.
I know. Yeah. So I mean, whoever wants to, say something.
Yeah.
Well, I can begin by saying something about this wry sense of humor that you just talked about. So, Hema was very fond of coffee, which perhaps some of you are aware. And when so Andal knows, there's this first floor. We have this little ledge kind of thing next to the student office. So one fine day, Hema says, "Let's make this into a coffee cabinet," and so we will have coffee every day at 11. And so I said yes. I was very new at the time. I mean, and said, yeah, we should do it. And so we both got together, got that cover, converted into a cabinet. We got a little microwave, we got a coffee machine, and then came the thing about buying the coffee, of course, after all this. And so then I was not that, what should I say, educated about the different kinds of coffee and so on. Then we did a lot of research, and we found that Big Basket, had a very good source of coffee that she would also enjoy. So then we did a Big Basket order, which was delivered to RRI and so on. So we were all set. And then we announced that this coffee cabinet is ready and so on. But unfortunately, we were the only two people who would have that coffee. So then, I mean, all that enterprise, but then somehow we couldn't convert. But then the one thing I learned is that a coffee is a seed and not a bean. So I always thought it's coffee beans, but she kind of, explained to me that no, it's a seed, it's not a bean. So I mean, so that was our coffee cabinet. So Hema and I had quite a bit of coffee because we bought it, together and finished it. And then when this happened I think after 2020, we have not really used that cabinet for any purpose really. So we just kind of, Anyway, so I'm sure there are many such stories that people can share. Deepa, I think the first time I met you was when you came to meet Hema at RRI. So would you like to share something? Yeah.
Well, it's difficult for me to express my words here, but my interaction with Hema started when I was a student and did my PhD in IIT Bombay. At that time, she used to visit Vijaya. We had not interacted at that time, so let me correct that. Later on, I was with Professor Deepak Mathur's lab for a short time. We were doing some femtosecond based work, and Hema used to visit, and suddenly the connect happened, and the experiment that I was doing was femtosecond laser writing on a piece of glass. We were trying to make waveguides several years ago. And it has nothing to do with what Hema's work was, but we just connected. We started talking about what happens to the material. The connect happened. And strangely enough, while I was in Bombay and now I'm in Chennai, in both these places, Emma had a relative very close to my house. So that was in Chembur, and here it was in Adyar. So we would come together and then coffee. We used to have good coffee together and generally talk about science, and that point I was, she's a figure to look up to, right? Give confidence that you could do science in a different way. You don't have to be, one thing I learned is you don't have to stick to a particular field, right? You could be equally good in multiple different things. I mean, every time I meet Hema, she would talk about some completely different thing that she's doing. Later, the bond grew stronger. She used to come to IIT Madras to meet her relative or otherwise also. Every time she would come to Chennai, we would meet. And the last we met was during, that was for the BRICS summit. It was a BRICS summit in Moscow. So she calls me and says, you have been nominated, I know. But this was a time when she had partially recovered in 2019? 2019 was it? Or 20?
No, I think it was 2018.
2018, yeah. 2018, yeah. And then she was struggling to walk, but no sign of, showing that she's unwell or used to hate to talk about that. And there too we were with, it was in January in Moscow, and in the middle of all the snow we would bathe and had fun, real fun. And some of these things, this was the first BRICS summit or something, and the Russians were proposing some virtual photonics institute, and it was the first time in a conference where I was attending where there was Russian translators. Everything was happening in Russian, and there was a translator sitting in the booth and translating everything for us. And very slyly they asked us to go on a sightseeing on the last day in the afternoon, while they were preparing the minutes of the meeting. And me and Hema would talk in Tamil and say, say that, no, let's not go. Let's sit and figure out what they are writing. It was some conclusion of the summit and so on. We should not give up. They should not let them take, so many different aspects in, how to conduct yourself, not just in the science, but in general, right? It was so much to learn from Hema. And the last message, I was just showing Urvasi that another brick, so I kept, I think we also were in that part of that. So the last October 2018, 2020, right? I got again the call for the BRICS meeting, and I see somebody else as the chairperson. And I immediately asked Emma, what happened? And then she said, no, I'm just not feeling little unwell. I'm little unwell, is what she said. So please, but then please don't give up. Please go and, represent our thoughts in the BRICS summit. And then I get a call from Andal. So I would really miss him. She's influenced me a lot. She was neither my PhD guide or postdoc guide or nobody in that sense. She had no business to mentor me, or rather, she was at such a senior position that she could have completely ignored me. But this is the influence that people around you can have on you, and she's really influenced. Thanks to Hema.
Actually, Hema and me, we are very close in age. I also graduated from IIT Bombay, and when we met up, there were very, very few women. Selling scientific instrumentation, none, and women scientists, very few. So, we have met a few times and stood up for each other, and small things. I mean, neither of us had children, so kind of, there were reasons behind that, I guess, which made us get close to each other. And coffee. I think all of us have got coffee stories, and I really, really miss her. Dr. Hema Ramachandran passed away, and Dr. Narayan also passed away. And, I think we have lost very uh, good persons and mentors and scientists.
Don't want to say a lot. Hema, I don't even know when she became a friend. We've shared a lot of things together. Whenever she came to Delhi, we were in the same DST committee, in the same PAC. We had fun together sometimes discussing about. She would always make sure she sat next to me. Images of that, images of sitting in the lawns here, discussing just all the lab troubles. Always came across, and I'm glad in some way my image of Hema got arrested at that age. Hema would never get old. And the under the experiment you mentioned, I have many, many, many stories. We also had some common friends in France, so it's the same group actually. I ran into her in France. She could not take the cold. Used to dress up in a very funny way, would have fun, and always complains. We had meals together even in Paris. And she visited me at Shiv Nara University. You did not? University? Yeah. Check your email 11 years back. So, first PR. But anyway, the point was that Hema visited me at Shiv Nara University. Shiv Nara from the Delhi International Airport is 2-hour drive. And not once, And the last experiment, Andal, you mentioned on the fog, it was actually done at Shiv Nara University, not in Paris. The fog was there, we arranged it. Hema was quite unwell. It got published after she passed away in 2021. And because it was amazing for me I was the Vice Chancellor, and because she came there, and she definitely, I knew the history. She was not that well, and it was really cold, foggy winter mornings, and we are trying to do this experiment. I put the head of the Department of Physics and some students to help, and she was staying at the guest house there, and taking a lot of sugar in her coffee because she was feeling very cold, which was a very bad thing to do, I told her. And it looked like, but the enthusiasm for that science and to do that experiment perfectly at that stage, I almost had tears in my eyes. When I saw her, and that's the last I remember. I gave her a hug and saying that, yeah, we got some data and hopefully that would work. I was terribly busy, could not spend much time, but she wrote me a very nice note afterwards, and then suddenly learned that she's no more. But I'm glad that she would stay like that enthusiasm, and she would not age in my mind. And she was always helpful, if I had a problem with some optics in my lab in JNU, and maybe I mentioned it, you get frustrated saying that, that's not working out. She would offer, saying that, maybe I can help you just from RRI, we'll do this and we'll do that. Always positive, always trying to find a way. And that I really, really appreciated even at that time. She was younger, no time to leave really, but anyway, she would stay like that with her sense of humor, that smile, and a passion for doing physics the right way. The right way. Even in that condition, she was making sure that the experiments happen exactly the way she planned, and then, of course, we helped. So I'm not. I'm thanked, I think, in that paper. I'm not a co-author. I did not want to be. I didn't contribute, but it was.
Rupa, just because it's in the public media, the paper which I highlighted is actually done in Paris.
Yes,
yeah, in
2014.
Yeah, so yeah, right.
But the last one that you're talking about, Andal, you mentioned that that she continued that study. The last one was actually done.
Yeah, the last. Yeah, I remember. Yeah, that's right. Where Fabian was involved.
So just imagine, what a spread, what a commitment, and it's really, really nice. At that time, I had met, of course, Andal, you, in Hema's lab, and those were really exciting times. We are trying to do something. I even remember Andal, I was saying, we are also working on EIT, and I was saying, I'm doing it. And her ear saying, don't say anymore, I'm working on similar stuff. So those were the days, and there are a lot of things happening. You're leading from the front, and I think Hema was the influence of Hema on all around her, on people who are senior to her, is just incredible. So it's just a good human being. I can't remember ever hearing her complain about anything, barring the cold. Yeah, she complained about the cold all the time. Yeah, yes. But in general, like we talk politics about science, never, never badmouth anybody, never talk that this. So there's always a positive side to Hema, and that I remember very, very strongly. So it's befitting that we're talking about her today, and I'm glad that you organized it. In some way, she's present, right, in this Women in Photonics conference. So thanks, Andal, for doing this. Thank you very
Oh,
much indeed. Thanks.
thanks.
Don't want to
Thanks.
say too much. I have too many stories, but that would stay with me actually. Thanks.
Does anyone else? I mean, I actually don't know who are the people who knew her well, and I just started picking people. But is there anyone I'm missing who wants to, say something? The food in China, I was saying, she would go with the khakra and she would go with food from here because she was a very staunch vegetarian. So, yeah. Which wouldn't go bad and so on. Yeah. So, yeah.
It's, talking about food, I remember that we both were in a conference at ICTP Trieste, and then again this coffee. I was not very fond of coffee or tea. I mean, if there's there, I'll take it. Otherwise, it's him as it is nonsense. There's no decent coffee here. So ICTP is in 7 kilometers or 8 kilometers away from Trieste main city. So she said, anyway, you said you wanted a walk. So we actually walked 8 kilometers to get good coffee. So it was a lovely walk, but such was the dedication to good coffee. So she also bought a coffee grinder at Trieste and said, we'll make now coffee. We wouldn't rely on ICTP coffees. Yeah.
Yes, please.
Yeah, I hardly knew Hema actually, but I met her twice. And the first time I met her, this was NLS IIT Delhi. And in the guest house we met. She came to my room, and we didn't talk about work. What we did was just talked a little. And one of the questions that she asked me, I remember, do you always wear saris to the lab or to the conference? So this stuck on, and I always kept thinking. Whenever I wore a sari, I would think, yeah, I remember Hema saying that. That's somehow, I mean, we don't talk about such things, but we did. Then the second time was NLS. RR and where she gave this talk on imaging in turbid media. And I want to mention that because my son was young, and my students' children were even younger, and they all sat through that. And when they were asked, "What did you understand anything?" Yes, we understood everything. Those little kids said that. So we said, "Okay, Hema, you see, these little kids also understood everything." So that's the only overlap I had with her. But very dignified lady.
She was very, very fond of sari herself, right? And this stitched salwar kameez. And even when this illness struck, and, we would discuss which wig was suiting her. So, I mean, she would experiment with that. And. So, yeah, I mean, if you keep talking, then you keep remembering things which you don't really think about unless, such conversations happen. But so, Andal, would you like to share any further thoughts?
I'm really glad that we got to talk about her science here, especially I was yesterday when I was thinking about it and putting the talk together. I realized she is one person who just so fitting for this conference, and I'm glad you gave me this opportunity to talk about her work. And I have nothing else to say. That if we imbibe the "let's do" spirit of Hema a little bit, I think we'll go a long way. I think that can do makes you do it better than can't do.
Sure.
Yeah. So yeah, thanks.
Thanks, Andal. And of course, we are holding a work conference on women in photonics and optics at RRI. So, I mean, it could not be held without at least doing something related to Hema. Unfortunately, without her physical presence, but I'm sure somehow we all perhaps are already imagining knowing her a little bit after this conversation. So I think with that, if there are no further comments or I guess there are no questions for this particular talk, so I will then thank Andal once more for agreeing to give this talk, and thank you all. Yeah.